Okay, so now we are on to module 2. Module 2 says define the term problem solving. This is always be a funny question for me, but you see, using analysis of a situation to come up with a solution that solves the issue at hand. I don't even want to put like, technical terms or technical solution or stuff like that. I don't know, it could be. Briefly describe 3 stages of the problem solving process. Well, define, could be 1, analyze. How much marks is this? Let me see. It's 6 marks. So 2 for each one here. Define, analyze, identify possible solutions. After you identify, add select. Then implement. And then review. Alright, any one of these you could choose 2 marks for each one of them, so you could go hard. Define would be to come up with a short statement about the problem. Analyze will be to find information, find data / information about the cause. Identify possible solutions. Right. We want to identify possible solutions, which will be come up with ways to solve it. Select and justify optimal solution. So select would be to choose the solution that solves it best. Implement will be to put the solution into practice. And then review would be evaluate to see if it was successful. Right. Yeah, any 3 of those should get here 6 marks. Those are standard things. That's kind of like fun stuff. This race user could contribute to an infinite loop. 3 issues that could be condition not being met as 1, 2 mathematical. What do you mean? 3 issues that can contribute to an infinite loop. It's definitely condition not being met, but we gotta go a little deeper than that because they want. Okay. Variables not being updated. Example, c is equal to c plus 1. Okay, cool. Variables declared within the loop. And what I would be, by example, for c is equal to 1 to 10, int c is equal to 0, or something like that. And a third one would be incorrect logic operator in condition. Example, c less than 5 when it should be c greater than 5. Yeah, that question was weird. That was a weird question, but no time to argue now. State two ways other than the use of flowcharts which algorithms could be represented. You could represent an algorithm with pseudocode or narrative. Yeah, pseudocode or narrative. Basically, that's what you want. Alright, the algorithm below is designed to determine the average weight in kilograms of a set of potatoes. The negative weight is entered to signify the end of input. In the space provided, draw a flowchart to represent this. Alright, to name it module average weight, but we don't need to put the module, but we could just say start. So start. Sum is equal to 0 and count is equal to 0, so we have to put it in a rectangle. Sum is equal to 0.0, count is equal to 0. Read weight definitely will be a parallelogram. While weight is greater than 0, that's a diamond for sure. Weight greater than 0. We have a yes. If the answer is yes, what do? We have a rectangle for sum is equal to sum plus weight. And then count is equal to count plus 1. And then we have to read weight, which is a parallelogram. So we read weight. And then we end the while. So when you end the while, this is going to run back up to the top of the while here, based on the weight that I read. Now from here, you're going to bounce up a if, so that's going to be a next diamond. So the no condition here is going to be like that. So we gotta check to see if count is greater than 0. Oh. Alright, so I need some space. Alright, so I'll put a yes. The answer is yes. What do? You have average is equal to sum divided by count. That's a rectangle there. And then we have to print average, which is a parallelogram. And then if our answer is no, what do? We print no data. And then we will all nice and mosey along, bounce up to stop. Cool. That wasn't that hard. Yeah, that was an easy question. How much marks are you giving for that? 12 marks? Way they're giving away marks, babe. That's a lot of marks for that. Thanks. Appreciate it. Alright, list 3 properties of a well-designed algorithm. This is This is literally C-sec work here. Usually have finite, precise, unambiguous, flow, and termination. I don't know if they want anything else like other than that, but you could go a little further and ensure that you seal the marks, seal the bag. So finite, all steps must have an end. Precise, the statements must be exactly what you want. Unambiguous, clear instructions. Flow, logical steps. Must have an end for termination. Or return. Something like that. Describe three control structures which can be used in structured programming. Oh, this is... Wow! This paper real easy so far, boy. It's a lot, yeah. Sequence. Selection. And looping. Or iteration. Sequence. Let's go to statements or instructions. Instructions. Read step by step in a logical manner. Selection. A choice between two statements is made based on a condition, and looping is a set of statements are repeated until a condition is met. Woo! Alright. That's so straightforward. Alright, the organizer of the Curve Games would like a program to manage the daily calculations of the bills of customers for the 2021 games. There will be 3 stands where customers can be seated. Bleacher, base cost $19 at a 5% discount. Grants, base cost 29%. Okay. Each record contains a customer number and the number of tickets that the customer would like to buy and desired stand. Based on the stand with its discount and the number of tickets, the program should determine the bill for each customer. It should also accumulate the total number of tickets sold for the day and the total revenue made on the day. Assume that the variables customer, number of tickets, and number of tickets choice is an integer, stand is a character, and bill revenue in this one. Write lines of pseudocode for a program to do the following. Initialize all the variables which require initialization. Right now, they're breaking this thing down into pieces. I'm very concerned. This is a little too easy. I swear you had to go and write out the whole algorithm here, but no, we're just writing it in pieces. Alright, number of tickets will be equal to 0 because it's a number. And revenue what else do we have to do? Number of tickets will be 0. Customer number, nothing. Number of tickets should start about 0. Choice is an integer. The choice, no, they get to put in their own choice, so you don't have to do that. The only other thing you have to initialize would be revenue, which will be a float, 0.0. Bill that'll be equal to 0.02 because those would be floats, or those would be real. Alright, so I would put integer because if you do not program, you want to tell them that, okay, make sure that these data types are that. Discount rate real. I can't see any other variable being needed to be initialized, because all the other, usually a variable that needs to be initialized would be a variable that you're going to calculate something into it. All the other variables that are being read into the system, they don't have to usually be initialized. But I mean, it's always a good thing to set everything to 0, but okay. Display or print to the screen a menu of the stand options, including the base course and the discount given, with an exit option, and try to get a choice. They want you to display a menu? That's print statements, so print. Welcome to the menu. Welcome to the games. And then print. Enter B for bleacher with enter B for bleacher, comma 19 USD, and then what, 5% discount. No, this can't be what they want. Maybe it is. Yeah, because they have an exit option. Okay, print. Well, let's go. Let's do what they say. Enter G for grandstand, comma, how much US this is? 29 USD and 3% discount. And then print, enter T for back side, which is 39 USD and no discount. Print, enter E to exit. This just wasting time in the exam, boy. Like, this just like, this just unnecessary writing. And then you'll have to read what? Input. What variable they have here? What variable they give us for the things that they could choose? Stand is a character, okay. So read stand. I am convinced this is this is trolling. This is trolling. What kind of easy question is this one? I could see students like making a mistake with this because they think it's too simple and they try to do something very complicated. But anyhow, read each variable value for the customer number of tickets from the keyboard. No. No. Read customer number and then read number of tickets. Well, that. Wow. Calculate the total bill for each transaction. Alright, so here's some work. Wow. Okay, so to calculate the we wanna say if we check the choice, stand is equal to B. B is the first one, B is bleacher. Yeah. If stand is equal to B, then they have a value for discount rates, do they? Discount rate, yeah. Then discount rate will be the 19%. And then the bill will be to multiply that thing, okay. Alright, so discount rates. Imagine I keep turning back pages all the time to see the question, but that's tough. That's tough. Discount rate will be equal to 0.05, so that's 5%. I think so, yeah. And there's a variable called base costs. Do they have that? Customer number, ticket choice, and bill revenue. No, they didn't give us that. So each record contains a number, a customer number, number of tickets, and the customer would like to buy based on his time, which is discount. So we have to get the number of tickets. Oh, we read the number of tickets already. We read the customer number and number of tickets. Okay. So we'll just call this cost is equal to the number of tickets. Multiplied by the US amount, which is 19 USD. So wait, this discount is a one-time discount for everything? Based on understanding which is discount the number of tickets the program should determine the bill of each customer. Alright, yeah. Okay, so the discount rate is when we find the total bill. So basically there's one if here. And we just had to repeat this process here. Okay. And say if stand is equal to next stand is G. If star is equal to G, then discount rate is equal to 0.03 because that would be 3%, right? Yeah, 3%. 0.03, and then their cost is equal to number of tickets multiplied by that cost. There is 29 USD. Yeah. Alright, so our last if now is if the stand is equal to, not G, what's the last one? The last one is T, 39 USD. Stand is equal to T, then discount rate is equal to 0. No, there is no discount rate. Why would I do that? That won't make any sense. Because 0 by something will give you 0. Okay, discount rate is equal to 0. And then we say cost is number of tickets. It would have been easier if I just had to write this whole thing out as one algorithm, because all of this piece kind of thing is just making it hard to write this down. Wait, there's more? Then display and output the customer number and bill in one statement. Yeah, boy. Alright. So I'm going to put bill is equal to cost minus cost multiplied by discount rate. There's clearly not enough space to write this. Clearly. Like, I don't know. No. Should I get a lot more space to write this? But it's cool. It's cool. We will take it. And then, alright, so once we get the bill, what else we need to get? Then display put the customer number and bill in one statement. Each transaction, then update the revenue and number of tickets. Calculate the bill for each transaction, then update the revenue and number of tickets. Alright, so revenue is equal to revenue plus bill. Alright, that's basically how much money you make. And then number of tickets. You have a variable for total number of tickets. Total number of tickets, here it is. Total number tickets is equal to total num tickets plus num tickets. We had assumed that this thing is in a looper, but they just want us to write the calculate the if statement. This is all that they're looking for inside here. Somehow I feel okay, you could do it like that. We don't have enough space for that, but I don't think they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines. What should I say? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Even if you do the short way, there's no way to get this done. Alright, once you do this in any way possible, you should be okay. Sometimes you can calculate and update the variables one time. I mean, you could aggressively code this out, but I ain't really gonna go through all that. This breaks it down. If you know how to break it down into smaller steps, by all means, go ahead. Once you get this stuff done. Alright, that's module 2. Alright, it's that time of the year again where it's time for crash courses, because you spent your whole year fighting up with school, not being able to go to school when you want to, always worrying about COVID, all kind of issues. So I have all the CSEC IT, CAPE IT, and CAPE Computer Science crash courses that you need. I'll be able to give you the whole syllabus in one quick dose to be able to get you over the hump. So here's how the crash courses will be going this year. So for all the crash courses, we have 3 different levels that you could choose from this year. Level 1 is video only. That's just a video that'll be about 6 to 8 hours long that covers the entire syllabus, going through and a kind of like a speed run, explaining every single thing, but not explaining every single thing, if you understand what I mean. Level 2 is a video and a class in April where you get to ask me anything about the syllabus. So you'll get the video in advance, you could watch it about 2 to 3 days before, and then you come to that class and then you ask whatever question you need to ask. And the third one is you get the video, you get that class, and you get access to our WhatsApp group directly to be able to ask me questions at any point in time whenever you're doing any past paper, whenever you're studying any work. And that's how the crash course is going to run this year. So the crash courses will be CSEC IT, CAPE IT Unit 1, CAPE IT Unit 2, CAPE Computer Science Unit 1, and CAPE Computer Science Unit 2. 2. Those are the days. Each one runs from 9 to 12. That's if you take the class option. You will be able to come into that class and ask any question about the syllabus, and of course you will get the video a few days in advance where you could watch through the whole thing. So what are the costs? Well, for all crash courses, CSEC and CAPE, Basic, which is the video alone, will be $150. $200 will be for the standard, and the Pro will be $250, which is the video, the class, and the WhatsApp group to ask questions at any point in time. So how do you register? You have to makeITsimpleTT.com/crash course, and you will be able to see all the courses that are available. You choose the one you want, you register, go through the payment, and then you will be given the video. Once you're given the video, you will be able to watch it at any point in time. Of course, if you register for the other ones, you'll be given the video and you'll be given the timetable of when your class is going to be. You'll be added to a Google Classroom. And if it's a Pro, you'll be given the video, you'll be given the class, and your phone number will be added to our WhatsApp group. So that's makeITsimpleTT crash courses. So I look forward to seeing you all. April, everything is going to be launched, so you can register from now, which is from March, for them. And you might just get the video before the end of March. And just in case you're wondering, these crash courses cover the new syllabuses. So the new syllabus for IT CSEC that launched a few years ago, the new syllabus for CAPE IT, and the new syllabus for ComSci. All the new stuff, all the things that they put into the syllabus that may not be always clearly explained, or the current textbooks don't have it, these crash courses have it. makeITsimpleTT.com/crash course. So I'll see you all there.